I'm a non-traditional student because I have 7 years of industry experience, so I'll be done in December. That's when my courses end. I came here specifically to learn communication systems, kind of the top level of the communication system, instead of going into the nuts and bolts of RF circuitry. The project that we're doing here, I'm working with one other graduate student, and we're trying to solve one of the problems in electrical engineering, which is that high-frequency chips or modern chips draw an awful lot of power. And it's starting to be a major industry concern, and if they don't know it yet, they will in a couple of years, to where they're going to have some serious problems. So we're solving that problem by transforming some of these electrical signals into optical signals, shipping them across chips as photons instead of electrons, which is kind of new for electrical engineering, then changing them back down into electronics and using them as the clock signal for the chip. So this project is a fairly innovative and advanced project to try and combine several areas of engineering, including electrical engineering, both from an analog perspective, and digital engineering and optics, all onto one chip to solve this problem of the chip takes too much power even when it's not doing anything. So we're taking these light signals, transferring them back down into electrical signals that are very weak. We're having to amplify them a lot to get them to be usable digital signals for the chip. And the future of this field, I think, is very exciting, because right now I'm an RF engineer, and the best RF engineers were back in the 60s, and the technology really hasn't changed much in the past 40, 50 years. But the applications have just exploded for RF engineers. It's a very exciting field to be in. You have all sorts of different applications like wireless networks and satellite communications and advanced radars that you didn't have 50 years ago, and all sorts of different communication systems. And on top of that, digital engineering is becoming more and more high frequency and more traditional RF. And there's a big mix of what people need to learn. Digital engineers are no longer just digital engineers, and analog engineers are no longer just analog engineers. Those two fields are merging as frequencies get higher and higher. And I think that's a very exciting time for an engineer who's trying to learn as much as they can, because you're not just learning one mindset. You're learning a bunch of different fields all in one degree, and each field is becoming more and more important to complete your education. So I think that's pretty exciting, especially for somebody who's in school and can come out with a well-rounded education, as opposed to somebody who's been limited to what they've done in the field for the past several years, and they may be a purely digital engineer or a purely something else engineer. Somebody in school can really explore different avenues. Getting a degree is not a high priority. It should not be your first priority when you're a graduate student. It's more the education that you're getting, the opportunity to explore different avenues that maybe you haven't explored before. When I graduated as an aerospace engineer, I knew nothing about electrical engineering, but that's where I decided to go because it was really fun for me. I see graduate school as the same way. I'm not here just to get a graduate degree. I'm here to enhance my education and come out as a more effective engineer. The old saying that you get what you put into it certainly applies to graduate school. Don't come here just to try and please a professor. Don't come here or any graduate school just to get a degree, but come here to learn as much as you can, to read as many white papers as you can, to explore avenues that you haven't had the opportunity to explore in the past. Research is a great way to do that.